Okay, so this is going to be a crash review of naming and writing compounds. And I thought the best way to do this is to just use problems and go over the rules as I'm going through some problems. And then at the end, I will review the rules for naming covalent compounds. So it says the chemical name for nickel 2 bromide is. So this Roman numeral is telling us the oxidation number for nickel. So they're telling us that nickel is +2. If it was a Roman numeral 3, then this would be +3. If it was a Roman numeral 1, then it would be +1. So I write the symbol, I put the +2 over it, and then I look up bromine, which is Br, and it's -1. And then I simply drop and cross. So I bring this here, and I bring this here. And then I wind up with NiBr2. What is the formula for titanium 2 oxide? That means titanium is going to be +2. We know oxygen is -2. So 2 to 2 is a 1-to-1 ratio. So it's simply going to be TiO. If I have 2 to 2, 3 to 3, 4 to 4, it's still 1-to-1. Which substance can be decomposed by a chemical change? This is the definition of a compound. 2 or more elements chemically combined, different elements chemically combined, that can be decomposed. So the key to doing this is table S. You will find 3 of these in table S, which means that they're elements. You will not find ammonia. It's actually a base, NH3, and it's found in table L. What is the UPAC name for the compound FeS? The UPAC name, whenever you see IUPAC, it's just the way that I taught you how to name it. Now, iron has more than one positive oxidation state because it's a transition element. Therefore, we have to use a Roman numeral. Sulfur is -2, and because these two combined at a 1-to-1 ratio, we know that they had to have used the +2 for the iron. So this would be iron Roman numeral 2 sulfide. Notice when we are naming or writing compounds, we simply name the first element, however it reads off the periodic table, and we take the second element and we're changing the ending to IDE. Decomposed by chemical means, again, I'm looking for a compound. Which formula represents lead 2 chromate? Well, lead, which is Pb, they're telling us to use the number 2. And chromate, we're going to look up anything that ends in 8 or ite, we look up in table E, and it's CrO4 -2. So this is 1-to-1, so it's simply PbCrO4. Remember, anything that contains more than 2 elements contains both ionic and covalent bonds. If it asks name the 2 bonds or both bonds, then it's always going to be ionic and covalent. Which statement describes the composition of potassium chlorate? Well, it's made of 1, 2, 3 elements, so it's not that. It's not made of 4. The proportion by mass of elements combined in potassium chlorate varies. The proportion by mass of elements combined in potassium chlorate is fixed. Well, they're going to be fixed because if we change the amount of the elements, then we're going to change the compound. Decompose by chemical means. Once again, we're going to look at Table S. 3 of these are elements, 1, 3, and 4. 2 is not in Table S. Octane is C8H18. It's an organic compound. Write the formula for iron 3 sulfide. They're telling us to use the +3 oxidation state. So Fe is +3, sulfur is -2. So when I drop and cross, I get Fe2S3. What is the name for the compound NH4Cl? So this has a polyatomic in it. So notice here, this contained a polyatomic in number 7. We named the element and named the polyatomic. There was no changing anything. Here, we're going to name the polyatomic and then take the ending and change it to "ide." So this is ammonium from Table E, and Cl is chloride. 2 different samples decompose when heated. One of the samples is soluble in water. So one is soluble in water, one isn't. So therefore we have two different compounds, because we can't have 2 different elements because elements don't decompose. The sample's decomposed, so we can't have elements, so nothing about elements. And they can't be the same compound because one was soluble in water and the other wasn't. Iron 2 sulfide, this is 2. I think we did this one already. This is -2. It's 1:1. FeS. A compound that's made of iron and oxygen only, the ratio of iron to oxygen is 2:3. So they have FeO, and this is 2:3. So that means our formula is going to be Fe2O3. Remember, as we drop and cross, we can go up and over. So this 3 came from here, and this 2 came from here. So we were talking about iron Roman numeral 3 oxide. Matter that is composed of 2 or more different elements chemically combined in a fixed proportion. This is the definition of a compound. Which list of formulas represents compounds only? Well, this is a diatomic element. This is a noble gas, and that's a compound. So only have one compound. That's not it. Magnesium oxide's a compound, sodium chloride's compound, and that's a diatomic element. H2N2O2 are all Brinkelhoff gases, and they are not compounds. They are diatomic elements. So that's not it. Here we have carbon dioxide, water, and ammonia. All 3 are compounds. Iron 3 oxide, so we're using the +3. Oxide is -2. So this was +3, this was -2, and then we drop and cross, and we get Fe2O3. Which type of matter is composed of 2 or more different elements chemically combined in a fixed proportion? Definition of a compound. Strontium phosphate. Strontium is Sr. It has a +2 charge. Phosphate is a polyatomic. It's found in Table E. And it's PO4 3-. So when we drop and cross, we get Sr3 PO4 2. Every water molecule has 2 hydrogen atoms bonded to 1 oxygen. Right? You've seen this picture 100 times. 2 hydrogens bonded to an oxygen. This fact supports the concept that elements in a compound are chemically combined in a fixed proportion, chemically combined in a proportion that varies, physically mixed, in a fixed proportion, or physically mixed in a proportion that varies. Well, if it's compound, you know right away they have to be chemically combined. And it has to be a fixed proportion. If I don't have two H's and an O, then I don't have water. If I have two H's, right, and two O's, then I've got H2O2. They're not the same thing. What is the formula of nitrogen 2 oxide? Same thing, they want you to use the Roman numeral 2 for nitrogen. So you've got N plus 2 and O minus 2. So it's simply NO. I'm going to go right to this. Write the chemical formula for sodium hydrogen carbonate. Sodium is Na, hydrogen is H, carbonate is in table E, it's CO3. Well, this is technically, the CO3 is technically 2 minus, and each one of these is 1 plus, so it balances out. So this is simply my formula, NaHCO3. I didn't even have to read any of that above stuff to answer this question. What is the chemical for tin 2 fluoride? Tin is Sn. They want us to use the plus 2. Fluorine is F minus 1. So when I drop and cross, I get SnF2. Write the chemical formula for baking soda. So I'm going to go up here. Baking soda is sodium hydrogen carbonate. I just did this for you. NaHCO3. Didn't need to read any of the rest of the stuff. Write the formula for the compound produced when arsenic is heated rapidly in air. Well, this is the only compound that is produced. So that's iron. Now, S is minus 2. Iron has more than one oxidation state, but in this case it had to be plus 2 because it combined with the S at a 1-to-1 ratio. And I take sulfur, change the ending to IDE. Write the name for washing soda. So now they want you to just write the name of this. So this is sodium hydrogen, and then you just look up CO3 carbonate. And last problem. It says at STP the density of copper is 3.3 times greater than the density of aluminum. Write the chemical formula of cuprite. Cuprite is the same as so it says two sources of copper are cuprite, which has the UPAC name of copper 1 oxide. So that's just copper 1 oxide then. Okay. Let's look at naming covalent. So this is all nonmetals, right? And we have to use prefixes like mono, di, tri, tetra, and penta. Okay? We don't need to do all of them. Mono means 1, di 2, tri 3, tetra 4, penta 5. So if the first element has 1, then no prefix is used. And then the second element always gets a prefix. For example, CO. There's 1 carbon. We don't use a prefix, so this is just carbon. Mono is 1, but we can't write monoxide, so it's monoxide. We have to drop the last letter. You can't have 2 vowels next to each other. Another one could be NO2. So this is just nitrogen because there's 1. And then there's 2 oxygens, so the prefix for 2 is di. So this is dioxide. Still ends in IDE because they're binary. Now, if they have multiple, then, so if multiple atoms are present, then prefixes are used on both. So, for example, so I have 2. So that's diphosphorus. So I'm just naming it. And then pentoxide. I just named the first one, carbon. And then 4 is tetra. Okay, those are some just general examples.